Hello. Right, so hopefully this should be the last video. The observant amongst you will notice that this section is now blank, so I am actually re-recording this because I made a very small error in recording the last question and I can't live with it, so we're re-recording this bit. Right, so a train manufacturer has developed a new braking system. The velocity time graph shows the velocity of the train from when the new brakes are applied until when it comes to rest. So estimate the train's deceleration at time 60 seconds. So what we're going to do is we're going to just highlight the point at 60 seconds. It's good to be formal about these things. So the acceleration on a velocity time graph is given by the gradient. So this line is not linear at all. So we are going to have to approximate the gradient, hence this estimate. So if I just get this to match as best I can, like so. So with my line here, hence why we're allowed to estimate. So I get this point here to be a height of 10. This point here we'll call 20 across. So this is 20, 40. That's absolutely fine. And this is 80, 10. So this is quite nice. So the gradient's given by the change in y over the change in x. In this case, it's the change in v divided by the change in t. So the change in v, so velocity has gone from 20 to, from 40 to 10. So it's 10 minus 40, so it's a decrease of 30. And then time has gone from 20 seconds to 80 seconds, so it's 80 take away 20. So it's going to be minus 30 divided by 60, so it's going to be minus 0.5 meters per second. So this negative aspect, it makes sense because it's a deceleration, but given that it asks for a deceleration, you can say deceleration of 0.5 meters per second, or you could say acceleration, because acceleration is a vector of 0.5 meters per second. So technically saying the positive one would technically be true because it's asked for deceleration. Okay, next part then. So let me just make sure everything's in frame. Calculate an estimate for the distance traveled by the train from the instant the brakes are applied until it comes to rest. Okay, so the distance on a velocity time graph is given by the area underneath, and we're told to use 4 strips of equal width. So given that it's from 0 to 80, we're going to split this as 20, 40, 60, 80. So 20, 40, 60, 80. So my points that they meet are here, 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 and here, and here. So we're essentially going to estimate this again. So again, estimating similar to the last question. So we want the area this time instead of the gradient. I'm going to do that by noting that this area can be approximated by a set of trapeziums and a triangle. So we need to now note the heights of these because we're going to use the trapezium rule. So this is 36. This would be 34. This would be 29. This would be 20, and this would be 0. So let me make a note of my points very quickly. So it's going to be 36, 34, 29, 20, 0. So the trapezium rule for area is h over 2 y0 plus yn plus 2 times the rest. So y0 is the first one, yn is the last one, and 2 times the rest is the middle step, 2 times the rest. So first plus last plus 2 times the rest, and then it's times by h over 2, and h is the width of each trapezium. So in this case, the reason we have trapeziums of equal width is so we can use it. So this distance here is 20, so is this one, and so is this one, and so on. So our h is very clearly 20. So just applying these to the formula now, nice and straightforward. So 20 over 2, and then it's going to be first, so 36 is first, plus last, which is 0, plus 2 times the rest, so 34 plus 29 plus 20. So I get this to be 10, and then 36 plus, so 34 plus 29 plus 20 times by 2. That's going to be 166. So that's 10 times by 202, which is going to be 2020. And again, just checking the units. So if we go back to this was velocity given in meters per second. So the distance we're going to get is going to be in meters. Explain how you could use the graph to gain more accurate estimate. Use more strips. I wouldn't say use more trapeziums because they weren't all trapeziums. There was one that was a triangle. Use more strips, e.g. 8. So instead of using 4 the width of 20, you could use 8 the width of 10, and then that would give you a more accurate estimate because you'd lose less area. Okay, so gardeners apply weed killer in large areas of land by using a spray gun. A gardening company has designed the bottle shown below. It consists of a hollow cylinder and a cone that are joined. The base radius of the cone and the radius of the cylinder are both 9 centimeters, so this is 9 centimeters. The height of the cylinder is 4 times the vertical height of the cone, so the height of the cone is h, and the vertical height of the cylinder is 4h. So the bottle has been designed so it has a capacity of 10 liters, so 1 liter is 1,000 centimeters cubed, so therefore 10 liters would be 10,000 centimeters cubed. So velocity of the cylinder would be, because a cylinder is a prism, so it's this circular area times by the length. So let's find an expression for both the cone and the cylinder and add them up, and then they should equal 10,000. So it's going to be 9 squared times pi times by 4h. So this is going to be 81 times by 4, so 324 pi h that would be. And then the volume of the cone is going to be 1/3 the base times the height. So the base area, again, is going to be 9 squared times pi, and the height is h. So this is going to be 81 divided by 3, so 27 pi h. So the volume in total is going to be these two added together. So it's going to be 324 plus 27. So it's 351 pi h. And that's going to be in centimeters cubed. So we know the total volume is 351 pi h, like so. So now what we need to do is 10,000 equals 351 pi h. So h equals 10,000 divided by 351 pi. So we get this to be 9 centimeters approximately. So then notice that the total height is 5h, so this would be 45 centimeters. Okay, so now let's do the last question and let's line these up so that we can see them. Right, so notice how first of all this has 5 notches on it, and the height is 5h, so each of these is h essentially, so it's going to be 9, 18, 27, 36, 45, and then weed killer is poured into the bottle at a constant rate. The cone is full of weed killer after 2 seconds. The bottle as a whole is full after 26 seconds. Using the axes below, sketch a graph of the height of the weed killer in the bottle during the 26 seconds it takes to fill. Right, so first thing to note then, the cone is full of weed killer at 2 seconds. The cone is 1h out of the 5, so it's a 5th full at 2 seconds, so it's 9 full. So this first point here is it's going to start here, and it's going to go to here. And then at the end, the bottle as a whole is full after 26 seconds. So bottle full at 26 seconds, so this point here. So now it's just had to determine how they get to each other, essentially. So what we need to look at is this cone here. So the cone is filled first. The cone's height is not going to fill at a constant rate. So the height is actually going to go up quicker initially and then slow down. So if you look at the cross-section for the cone, it's actually getting bigger and bigger. So it takes more volume, more fluid to increase the height the higher up you get. So it's going to start out increasing height quite quickly, and then you're going to get diminishing returns. So what that'll look like is it starts out really fast and then levels off like so. And then when it gets to this point here, it's a circle. It's just a constant cross-section the entire way up. So that means it's going to fill at a constant rate, and constant rates are linear. So we use a ruler, straight line, and there we go. That's our answer. So your graph should look somewhat like that.